Welcome to Shekhar Maths. Today we are going to learn 7th class Mathematics Semester 1 first chapter Integers exercise 1.3 based on properties of integers. Before going to do the exercise, let us learn the concept. In 6th class we studied the properties of whole numbers. Now let us recall the names of those properties. Number 1, closure property, Samvrata Dharmamu, in addition, subtraction, multiplication and division operations. Number 2, commutative property, Vinimaya Dharmamu, Leka Sthityantara Dharmamu. Number 3, associative property, Sahachara Dharmamu. Number 4, identity property, Tatsamamsha Dharmamu, in addition and multiplication operations. Number 5, inverse property, Viloma Dharmamu, in addition and multiplication operations. Number 6, distributive property, Vibhaga Nyayamu. Now, let us study in detail these properties in integers. Now, let us take first property, closure property. Observe the following and complete the tables. Addition, statement 1. Minus 5 plus 3 gives minus 2. Here, minus 2 is an integer, so the sum is an integer. Minus 3, minus 2 are two different integers, but their sum is minus 5 is also an integer. 0, minus 3 are two different integers. By adding we get minus 3. The sum is an integer. 7 plus minus 6, that is equal to 7 minus 6, which is equal to 1. So the sum is also an integer. Here observe that the right side numbers are all integers. So the operation plus, that is the sum of any two integers, is also an integer. So we can say that if a, b belongs to z, then a plus b belongs to z. So therefore integers are closed under addition. Now let us take multiplication. Statement 1. Minus 5 into 3 is minus 15. Minus 5, 3 are two different integers, but their product minus 15 is also an integer. Statement 2. Minus 3 into minus 2. Minus into minus is plus, 3 into 2 is 6. So 6 is an integer. Now 0 and minus 3 are two different integers, but their product is 0 is again an integer. 7 into minus 6 plus into minus is minus. 7 into 6 is 42. So minus 42 is again an integer. Here observe that the right side numbers are all integers and the operation we used are multiplication. So the product of any two integers is again an integer. So we can say that if a, b or any two integers belongs to z, then a into b also belongs to z. So we can say that integers are closed under addition and multiplication. Now let us think. Can you find at least one pair of integers whose sum or product is not an integer? The answer is no, because we studied from the above tables that the sum of any two integers we are getting an integer. The product of any two integers is again we are getting an integer. So the answer is no. Let us study the closure property in subtraction and division operations. Now let us take first subtraction. Take two different integers, minus 7 and 8. Put subtraction, that is minus in between them. Now see that minus 7 and minus 8 is equal to minus 15. Minus 15 is again an integer. Take minus 5 and minus 3, two different integers, and put subtraction minus in between them, that is minus 5 minus of minus 3 is equal to minus 5 plus 3, which gives minus 2, again an integer. Now 0 minus of minus 3 is equal to 0 plus 3, that is equal to 3, is again an integer. Now 9 minus of minus 6, that is equal to 9 plus 6, which is equal to 15, is again an integer. So here observe that all the result, the difference is again an integer. Operation we used here is subtraction. So the difference of any two integers is again an integer. So we can say that if a, b or any two integers belonging to z, then a minus b also belongs to z. Therefore we can say that integers are closed under subtraction. Now let us observe the operation division. First statement. Here 9 and 10 are two different integers. When 9 is divided by 10, we get 0.9. But there is no integer like 0.9. So 0.9 is not an integer. Now Minus 6 divided by minus 2. Minus minus get cancelled. 2 3s are. So answer is 3. So the quotient is an integer. 0 divided by minus 3. 0 divided by any number gives 0. So 0 is an integer. 7 divided by minus 6 gives plus divided by minus is minus. So minus 7 by 6 is not an integer. So after division, the quotient we get minus 7 by 6 is not an integer. So here observe that in the first and the fourth examples, the result is not an integer. The quotient is not an integer. So the operation we use here is division. So in general, the quotient of any two integers is not an integer. So we can say that AB belongs to Z, then A divided B does not belong to Z. So integers are not closed under division. Now let us take the second property, commutative property. Observe the following and complete the tables. Let us take the operation addition. In statement 1, let us take two different integers minus 6 and 3. Just add it. Minus 6 plus 3 gives minus 3. Now in statement 2, interchange the integers. That is, first 3 comes and then minus 6. And put addition plus. That is 3 plus of minus 6 gives the same result minus 3. So in conclusion we can say that minus 6 plus 3 equal to 3 plus minus 6. Now in second example take 3 minus 9 different integers. Just add it. 3 plus minus 9 gives minus 6. Now interchange the numbers. Minus 9 plus 3 also gives minus 6. So we can say that 3 plus minus 9 is equal to minus 9 plus 3. Now let us take minus 6 minus 5. Add them. Minus 6 plus minus 5 gives minus 11. Now interchange the numbers. Minus 5 plus minus 6 also gives minus 11. So we can say that minus 6 plus minus 5 equal to minus 5 plus minus 6. Now let us take minus 3 plus 2 gives minus 1. Now interchange them. 2 plus minus 3 also gives minus 1. So we can say that minus 3 plus 2 is equal to 2 plus of minus 3. And last 4 plus of minus 5 gives minus 1. And interchange them. Minus 5 plus 4 is also gives minus 1. So 4 plus of minus 5 is equal to minus 5 plus 4. From the above examples, we observe that adding any two integers and interchanging and adding the same integers give the same result. So for any two integers, we can say that a plus b is equal to b plus a. So therefore, integers are commutative under addition. Now let us take multiplication operation. In first statement, take two different integers minus 6 and 3. Just multiply it. Minus 6 into 3 gives minus 18. And now interchange them. 3 into minus 6 also gives minus 18. So in conclusion we can say that minus 6 into 3 is equal to 3 into minus 6. Now in second example, 3 into minus 9 is equal to minus 27. Minus 9 into 3 is also gives minus 27. So we can say that 3 into minus 9 is equal to minus 9 into 3. Now in third example, minus 6 into minus 5 is equal to 30. Interchange them. Minus 5 into minus 6 also gives 30. So we can say that minus 6 into minus 5 is equal to minus 5 into minus 6. Now minus 3 into 2 gives minus 6. Interchange them. 2 into minus 3 also gives minus 6. So we can say that minus 3 into 2 is equal to 2 into minus 3. Last, 4 into minus 5 gives minus 20. Now interchange them. Minus 5 into 4 also gives minus 20. So we can say that 4 into minus 5 is equal to minus 5 into 4. Products we are getting after multiplying any two integers is same as the product when they are interchanged and multiplied together. So here we are using the operation is multiplication. So for any two integers AB belongs to Z, A into B is equal to B into A. So therefore integers are commutative under addition and multiplication. Now let us observe the commutative property under subtraction and division. First let us take the operation subtraction. For this take any two integers minus 6 and 3. Put minus in between them. Then we get minus 6 minus 3 is equal to minus 9. Now interchange them. 3 minus of minus 6. We get 3 plus 6 that is equal to 9. Minus 9 and plus 9 are not equal. So conclusion is minus 6 minus 3 is not equal to 3 plus minus 6. In the same way, 5 minus of minus 9 gives 5 plus 9 that is equal to 14. By interchanging minus 9 minus 5 we get minus 14, that is 14 and minus 14 are not equal. So we can say that 5 minus of minus 9 is not equal to minus 9 minus 5. Now here observe the not equal to symbol in the conclusion. So for any integers a and b we can say that a minus b is not equal to b minus a. Therefore integers are not commutative under subtraction. Now let us take the operation division. Let us take two integers 2 and 10. First divide 2 by 10, that gives 0.2. Now interchange them. Now 10 divided by 2, it gives 5. So 0.2 is not equal to 5. So in conclusion we can say that 2 divided by 10 is not equal to 10 divided by 2. Now let us take another example, 3 minus 9. First divide 3 by minus 9, we get minus 1 by 3. Now interchange them. Minus 9 divided by 3. 3 3 ja, that is minus 3. Minus 1 by 3 minus 3 are not equal. So in conclusion we can say that 3 divided by minus 9 is not equal to minus 9 divided by 3. Now here observe the not equal to symbol in the conclusion. So for any two integers a and b, we can say that a divided by b is not equal to b divided by a. Therefore integers are not commutative under subtraction and division. Third property, associative property. Here in this property we will take three different integers. Let us take the operation addition. In statement 1, first put bracket for the first two integers. In statement 2, first put bracket for the last two integers. Now in statement 1, minus 6 plus 3 gives minus 3, plus 2 becomes minus 1. In statement 2, minus 6 plus 3 plus 2 becomes 5. So minus 6 plus 5 equal to minus 1. Here both are equal. So in conclusion we can say that minus 6 plus 3 plus 2 is equal to minus 6 plus 3 plus 2. Now in the second example, 3 plus minus 9 gives minus 6 plus minus 5 gives minus 11. In statement 2, 3 plus minus 9 plus minus 5 becomes minus 14. So 3 minus 14 is minus 11. Now both are equal. So we can say that 3 plus minus 9 plus minus 5 is equal to 3 plus minus 9 plus minus 5. Now third example, minus 6 plus minus 5 becomes minus 11 plus 6 equal to minus 5. In statement 2, minus 6 plus minus 5 plus 6 equal to 1. So minus 6 plus 1 is minus 5. Both are equal. So we can say that minus 6 plus minus 5 plus 6 equal to minus 6 plus minus 5 plus 6. Here observe the equality symbol in the conclusion. So we can say that for any three integers a, b and c, a plus b plus c is equal to a plus b plus c. Therefore integers are associative under addition. Now let us take the operation multiplication. Take three different integers minus 6, 3 and 2. In statement 1, put bracket for the first two integers. In statement 2, put bracket for the last two integers. Now in statement 1, minus 6 into 3 is minus 18, into 2 is minus 36. In statement 2, minus 6 into 3 into 2 is 6, minus 6 into 6 is minus 36. Both are equal. So in conclusion we can say that minus 6 into 3 into 2 is equal to minus 6 into 3 into 2. Now in second example, statement 1, 3 into minus 9 is minus 27, into minus 5 is 135. In statement 2, 3 into minus 9 into minus 5 is 45. So 3 into 45 is 135. Both are equal. So we can say that 3 into minus 9 into minus 5 is equal to 3 into minus 9 into minus 5. Now in third example, statement 1, minus 6 into minus 5 is 30, into 6 is 180. In statement 2, minus 6 into minus 5 into 6 is minus 30, minus 6 into minus 30 is 180. Both are equal. So in conclusion we can say that minus 6 into minus 5 into 6 is equal to minus 6 into minus 5 into 6. Now observe the equality symbol in the conclusion. So we can say that for any three integers a, b, c, a into b into c is equal to a into b into c. Therefore, integers are associative under addition and multiplication. Now, associative property in subtraction and division operations. Now take subtraction. Here we are taking three different integers minus 6, 3 and 2 and put minus in between them. Now in statement 1, put bracket for the first two integers. In statement 2, put bracket for the last two integers. Now in statement 1, minus 6 minus 3 becomes minus 9 and minus 2 equal to minus 11. In statement 2, minus 6 minus of 3 minus 2 becomes 1. So minus 6 minus 1 equal to minus 7. Here minus 11 minus 7 are not equal. So in conclusion we can say that minus 6 minus 3 minus 2 is not equal to minus 6 minus of 3 minus 2. Now example 2, statement 1, in bracket 3 minus of minus 9 gives 3 plus 9, that is 12, minus of minus 5 becomes plus 5. 12 plus 5 is equal to 17. Now in statement 2, 3 minus of minus 9 minus of minus 5, that is minus 9 plus 5, that is 3 minus of minus 4, that is 3 plus 4 is equal to 7. 17 and 7 are not equal. So we can say that in conclusion 3 minus of minus 9 minus of minus 5 is not equal to 3 minus 9 minus of minus 5. Here observe the inequality symbol in the conclusion. So in general for any three integers a, b, c, a minus b minus c is not equal to a minus of b minus c. Therefore integers are not associative under subtraction. Now let us take the associative property in the operation division. Here we are taking three different integers minus 18, 6 and 3. Now in statement 1, minus 18 divided by 6 gives minus 3, divided by 3 gives minus 1. In statement 2, minus 18 divided by 6 divided by 3 gives 2. So minus 18 divided by 2 gives minus 9. Here minus 1 minus 9 are not equal. So we can say that in the conclusion minus 18 divided by 6 divided by 3 is not equal to minus 18 divided by 6 divided by 3. Now example 2, statement 1, 16 divided by minus 4 gives minus 4 divided by minus 2 equal to minus minus or get cancelled 2 2 ja, that is equal to 2. In statement 2, 16 divided by minus 4 divided by minus 2 gives 2 2 ja, that is 16 divided by 2, that is equal to 8. So here 2 and 8 are not equal. So in the conclusion we can say that 16 divided by minus 4 divided by minus 2 is not equal to 16 divided by minus 4 divided by minus 2. Observe the not equal to symbol in the conclusion. So in general for any three integers a, b and c we can say that a divided by b divided by c is not equal to a divided by b divided by c. Therefore integers are not associative under subtraction and division. Number 4, identity property. Identity means equality or same value. Let us take the operation addition. In addition, if any number is added to 0 or 0 added to any number, we get the same number. No change in the value. So it remains same. For example, 3 plus 0 equal to 3. 0 plus minus 3 equal to minus 3. Minus 2 plus 0 gives minus 2. 0 plus 5 gives 5. Minus 6 plus 0 gives minus 6. That is, there is no change in the number. So for any integer a plus 0 is equal to 0 plus a is equal to a. So therefore 0 is the additive identity. Now let us take the operation multiplication. If any number is multiplied with 1 or 1 is multiplied with any number, we get the same number. There is no change in the number. Let us take an example. 3 into 1 gives 3. 1 into minus 3 gives minus 3. And minus 2 into 1 is minus 2. 1 into 5 is 5. Minus 6 into 1 is minus 6. There is no change in the value of the number. So for any integer a into 1 is equal to 1 into a is equal to a. Therefore 1 is called the multiplicative identity. Now number 5, inverse property. Let us take in addition. What should be added to minus 3 to get additive identity 0? Observe that 4 plus minus 4 equal to 0. Here additive inverse of 4 is minus 4. Minus 5 plus 5 is equal to 0. Additive inverse of minus 5 is 5. Minus 6 plus 6 equal to 0. So additive inverse of 6 is minus 6. So we can say that for any integer a, there exists another integer minus a such that a plus minus a is equal to minus a plus a is equal to 0. So to get the additive inverse of any integer a, we just multiply minus 1 to a. Example 7. Find the additive inverse of plus 2 and minus 3. Solution. Additive inverse of plus 2 means just change the sign minus 2. Additive inverse of minus 3, just change the sign plus 3. Now write all the additive inverses of 5, minus 8, 1 and 0. They are minus 5, plus 8, minus 1 and 0 because there is no sign for 0. What should be multiplied by 6 to get multiplicative identity 1? Is it exists in integers? No, because 6 when multiplied by 1 by 6, on simplification by 6, 6 1 ja, that is equal to 1 into 1 is 1. So multiplicative inverse of 6 is 1 by 6, but 1 by 6 does not exist in integers. Sixth property, distributive property. Let us take 3 integers minus 2, 1 and 3. Number 1, minus 2 into 1 plus 3 is equal to, here minus 2 is distributed to 1 and 3 as minus 2 into 1 plus minus 2 into 3. On the left hand side, minus 2 into 1 plus 3 becomes 4 is equal to, on right hand side, minus 2 into 1 is minus 2, minus 2 into 3 is minus 6. So on the left hand side, minus 2 into 4 is minus 8. On right hand side, minus 2 plus minus 6 is minus 8. Both are equal. Now let us take 3 integers, minus 1, 3 and minus 5. On the left hand side, minus 1 into 3 plus minus 5 is equal to, minus 1 is distributed to 3 and minus 5 as minus 1 into 3 plus minus 1 into minus 5. On left hand side, minus 1 into 3 minus 5 becomes minus 2 is equal to, on right hand side, minus 1 into 3 is minus 3 plus minus 1 into minus 5 is plus 5. So on the left hand side, minus 1 into minus 2 is 2. On right hand side, minus 3 plus 5 is 2. Both are equal. So we can say that for any integers a, b and c, a into b plus c is equal to a into b plus a into c. Here a is distributed to b and c. Now let us see multiplication of two or more negative numbers. For convenience sake, we are taking a minus 1 as a negative integer. Observe it. First, minus 1 into minus 1. 2 times so minus 1 is multiplied. Then minus into minus is plus. 1 into 1 is 1. So plus 1. If minus 1 is multiplied 3 times. Minus 1 into minus 1 into minus 1. Minus into minus is plus. Plus into minus is minus. So minus 1. When minus 1 is multiplied 4 times. Minus 1 into minus 1 into minus 1 into minus 1. We get plus 1. When minus 1 is multiplied 5 times, minus 1 into minus 1 into minus 1 into minus 1 into minus 1, we get minus 1. Here observe that if we multiply a negative integer even number of times, that is 2 times, 4 times, we get the product is plus 1, that is a positive integer. When a negative integer is multiplied odd number of times, that is 3 times, 5 times, then we get minus 1, that is a negative integer. Now example 8. Multiply the following using associative law. 1, 2. Solution 1. Minus 25 into minus 4 into 2 into minus 8. Here group the numbers which give 100, 1000, That is, here observe that minus 25 into minus 4 is 100 into 2 is taken into minus 8. That is 100 into 2 is 200. 200 into minus 8 is minus 1600. Number 2. Minus 20 into minus 2 into minus 5 into 7. Here group the numbers in such a way that where we get 10, 100. Here observe that minus 2 into minus 5 is 10. So minus 20 is taken outside into minus 2 into minus 5 in bracket into 7. That is minus 20 into minus 2 into minus 5 is 10 into 7. Now minus 20 into 10 is minus 200 into 7 is minus 1400. Now example 9, or minus 42 into minus 7 and minus 7 into minus 42 equal. Write the law. Solution. Minus 42 into minus 7 gives plus 294. Minus 7 into minus 42 also gives plus 294. That is, products are same. But observe that the numbers are interchanged. Here the operation used is multiplication. Even though numbers are interchanged, the products are same. So it is multiplicative commutative law. Now example 10. Simplify 26 into minus 48 plus minus 48 into minus 36 using suitable laws. Here first expression is numbers are interchanged. 26 into minus 48 is written as minus 48 into 26. And second number is same as minus 48 into minus 36 using commutative law. That is equal to, here observe that minus 48 is common in both the expressions. So it is taken outside. So minus 48 into 26 plus minus 36 are written in a bracket. That is distributive law. Now in bracket it can be written as 26 minus 36 becomes minus 10. So minus 48 into minus 10 is 480. Now let us do exercise 1.3. Number 1. Identify the laws in the following statements. Solution 1. Minus 3 plus 5 is equal to 5 plus minus 3. Here observe that minus 3 and 5 are interchanged on left side and right side. So, and the operation used here is plus. So this is the commutative property under addition. Sankalana vinimaya dharmamu leda sthityantara dharmamu. Next, solution 2. Minus 2 into 1 is equal to 1 into minus 2 is equal to minus 2. Here observe that the number minus 2 is multiplied by 1 and it is not changing its value. So this is called the identity property, and here 1 is called the identity element. The operation used here is multiplication. So multiplicative identity gunakara tatsamamshamu. Next, solution 3. Minus 5 into 2 in bracket into 3 is equal to minus 5 into in bracket 2 into 3. Here observe that there are 3 different integers, minus 5, 2, 3, and the operation used here is into. So it is called the associative property under multiplication. Gunakara sahachara dharmamu. Now number 4. 18 into in bracket 7 plus minus 3 is equal to 18 into 7 plus 18 into minus 3. Here observe that here 18 is distributed to 7 and minus 3. So it is called the distributive property. Vibhaga nyayamu. Solution 5. Minus 5 into 6 equal to minus 30. Here observe that the product of two integers is again an integer. Here operation is into. So closure property under multiplication. Gunakara samvrita dharmam. Now last, solution 6. Minus 3 plus 0 is equal to 0 plus minus 3 is equal to minus 3. Here observe that the value of minus 3 is not changed by adding 0, and the operation used here is plus. So here 0 is called the additive element. So identity property under addition. Sankalana tatsamamsha dharmamu. Next, number 2. What will be the sign of the product of the following? Number 1, 2. Solution 1. 24 times of negative integer. Let us take minus 1. Minus 1 into minus 1 into minus 1, 24 times. So put a bracket for each pair. Then in each pair there are two negative numbers. That is minus into minus is plus. So we get plus 12 times because 24 can be written as 2 into 12. So that is equal to product of plus any number of times, that is 12 times, also gives positive, that is a positive integer. Another way, 24 times negative integer. Here 24 is an even integer, so the result is a positive integer. Now, solution to 35 times of negative integer, that is minus 1 into minus 1 into minus 1, 35 times. Here put bracket for each pair of negative numbers. In each pair there are two negative numbers, that is minus into minus is plus. Now we can write 35 as 34 plus 1. 34 is 2 into 17 plus 1, that is plus comes to 17 times and a negative number, that is at last plus into minus is equal to minus. So that is product is a negative integer. In another way, 35 times a negative integer. 35 is odd integer, so the result is a negative integer. Now 3. Write the numbers in the blanks by using appropriative law. Solution 1. Minus 3 when added to which number, the same minus 3 comes. It is nothing but added to identity element 0. That is minus 3 plus 0 is equal to minus 3. So this is called the identity property under plus. Sankalana tatsamamshamu. Now solution 2. 2 into minus 3 is equal to minus 3 into how much number? Here observe that 2 and minus 3 are interchanged and the product is equal. So here the operation used is into, so it is called the commutative property under multiplication. Gunakara vinimaya dharmamu. Now solution 3. Minus 6 plus 3 plus minus 2 is equal to minus 6 plus dash dash. Here observe that there are three different integers, minus 6, 3, minus 2. So in the bracket 3 minus 2 comes, and observe that it is a associative property and operation used here is plus. So it is called the associative property under addition. Sankalana sahachara dharmamu. Solution for minus 6 into how much is minus 6? Minus the value of minus 6 is not changed in multiplication. It happens only when it is multiplied by 1. And the operation used here is into. So it is called the identity property under multiplication. Gunakara tatsamamsha dharmamu. Now solution 5. 5 into in bracket minus 6 plus 9 is equal to dash into minus 6 plus 5 into dash. Here observe that the number 5 is distributed to minus 6 and 9. So in first blank 5, in last blank 9. So it is called the distributive property. Vibhaga nyayamu. Now number 4. State true or false. Give the reasons. Solution 1. 2 is the multiplicative identity of minus 2. We know that minus 2 when multiplied with 1 gives minus 2. Here 1 is called the multiplicative identity. So the above statement 2 is the multiplicative identity is false. Next, solution 2. Integers are commutative under subtraction. Let us take any two integers 3 and 2 and put subtraction in between them. 3 minus 2 gives 1. 2 minus 3 gives minus 1. They are not equal. So integers are commutative under subtraction statement is false. Solution 3. For any two integers a and b, a into b is equal to b into a. Let us take two different integers 5 and 6. Just multiply them. 5 into 6 is 30 and interchange it. 6 into 5 is also 30. Both are equal. So the above statement is true. Solution 4. The division of integer by 0 is not defined. True, because take an integer 5, divide it by 0. We cannot divide 5 by 0 or any integer. So the above statement is true. Last, solution 5. 6 plus minus 6 equal to minus 6 plus 6 equal to 0 indicates additive identity property. In the above statement, the additive identity 0 is not added. Instead, answer is 0. So the above statement is false. Now number 5. Simplify the following using suitable laws. 1, 2. Solution 1. Here observe that there are three different integers, minus 11, minus 25, minus 4. So we have to use associative property. Now let us take the product of any two integers. Minus 11 into minus 4 is 44. Minus 25 into minus 4 is 100. We have to group the integers in such a way that whose product is 10, 100 and so on. So first group the first two integers. That is equal to Now group the last two integers. This is using associative property under multiplication. Now minus 11 into minus 25 into minus 4 is 100. Now a negative number into positive number becomes a negative integer using closure property under multiplication, that is equal to minus 1100. Now solution 2. 3 into minus 18 plus 3 into minus 32. Here observe that 3 is common in both the products. So 3 into is taken outside. So 3 into in bracket put minus 18 plus minus 32 using distributive property. Now 3 into in bracket two negative integers. Sum of two negative integers is again a negative integer. Minus 18 minus 32 gives minus 50 using closure property under addition. Now 3 into minus 50 is minus 150 using closure property under multiplication. Number 6. Are the integers associative under subtraction? Explain by an example. Solution. Here I am taking three different integers 6, 4, 2. Now put minus in between them. 6 minus 4 minus 2. Right side 6 minus 4 minus 2. Now put bracket for the first two integers. 6 minus 4. Right side 4 minus 2 integers. Now 6 minus 4 we get 2 minus 2. On right side 6 minus 4 minus 2 gives 2. Now left side 2 minus 2 is 0. Right side 6 minus 2 is 4. But 0 is not equal to 4. So we can say that the integers are not associative under subtraction. Now number 7. Verify minus 5 into minus 2 into 3 is equal to minus 5 into 2 into 3. Here observe that there are three different integers minus 5, 2, 3 on both sides. So it is a multiplicative associative property. Now in bracket minus 5 into 2 is minus 10 into 3. On right side minus 5 into 2 into 3 is 6. Now left side is minus 10 into 3 is minus 30. Right side minus 5 into 6 is minus 30. Both are equal. So associative property is verified.
Thanks for watching video. Don't forget to subscribe. Say Math.